High demand for a firm's products is great, but high profits are even better. In this lesson, we'll talk about the relationship between demand, costs, and profits. Let's look at the following example. A firm rents a movie theater. It pays $40,000 monthly rent. The cost of personnel it pays to operate the place is another $20,000, and 12,000 people visit the cinema every month. Each of these customers spends an average of $12. A large portion of the box office receipts is paid to movie creators and distributors. The cinema and movie owners split the ticket 50-50, and, for simplicity, we'll hypothesize there are no other sources of revenues and expenses. Let's do a few calculations. 12,000 people visit the cinema and pay an average of $12 per ticket. This gives us revenues of $144,000. However, half of these revenues are then paid to movie creators, so the company is left with $72,000. Its rent and staff expenses amount to $60,000, which leaves us with a bottom line of $12,000. Okay, excellent. Now we'll need a few definitions. Let's start by looking at the cost structure of the firm. There are two types of costs, variable and fixed costs. In our case, the money paid to movie producers is a variable cost, right? It grows proportionally to the number of tickets sold by the cinema. If it sells one ticket, $6 will be owed, and when it sells 12,000 tickets, $72,000 is owed. For each ticket sold, the firm pays $6. Simple as that. What about the cost of personnel and rent expenses? Are these variable costs too? I don't think so. The firm will have to pay rent, even if no one shows up to the cinema. Personnel who work there will expect the same salaries if they have 1 or 10,000 visitors. Therefore, we can conclude these are fixed costs that are not dependent on the number of tickets sold, as long as the firm operates this cinema. These definitions are useful as they help us understand one thing. All else being equal, a firm must sell enough units to cover its fixed costs. There are economies of scale. If we sell more units, the fixed cost per unit decreases, and the business has a chance to break even and profit. We can look at our example in the following way. Number of tickets sold multiplied by a ticket's price minus variable costs equal to 50% of ticket's price times the number of tickets sold minus fixed costs of $60,000. This gives us $12,000. Let's calculate the break-even point now. What is the number of tickets that would allow the company renting the cinema to break even? In this equation, the number of tickets sold becomes our unknown x. We would have $12 multiplied by x minus $6 multiplied by x minus $60,000, and this is equal to 0. So basic algebra allows us to solve for x and obtain that x is equal to 10,000. If the cinema theater sells 10,000 tickets or more, it won't lose any money. If it sells less than 10,000, it will lose money. The notions of variable and fixed costs and break-even analysis we showed here are very helpful when we have to determine the optimal price point for a product. These are the tools that would allow us to improve our decisions in terms of target volume sold and pricing. You can reinforce what you learned in this lesson by solving the exercise provided in the download section. This will do for now. Thanks for watching.